Hi friends, welcome to Civil Architecture Tutorials. Today's subject is regarding the column reinforcement design. That is some of the major points that we need to remember or we need to know when we are at site or when we are doing the reinforcement part of the column. So let us start with the first point. First point is column lapping should be less than or equal to 50% at a section. That means when we take a section of the column lapping, we had to see only 50% or equal to 50% lapping should be there. That means in some of the sites in which I visited, I have seen that, or you might also have seen that from the at the top of the roof, you can see some reinforcement bars coming up for columns, and maybe it's for later use. Okay, but how they are giving is that maybe the steels that are coming, the steel bars that are coming from the column, if it is four, that sample as four, maybe six, it could be six bars coming up from the column shoe will end up at the same height. That is, the length will be the same. So what will happen when we are going for the next column? It will be a problem for that. So for that, it should be like this. That is, if this is the column shoe and these are the four bars, take the sample of four bars. Four column bar coming up. One is this, one is small, one is big, one is small. So there are two big and two small, one at different length. So that the lapping will be correct. That is what this is what it is saying. Column lapping should be less than 50% of the section. If we cut a section here, if you cut a section here, you know, the lapping will be, there will be one lap here and the second lap is here. There is no other lap here in between. If you cut a section here in this side, there are two laps only here, other two there is no lap. So that is what I meant by lapping should be equal to or less than 50%. That means it should not, or the lapping should not come at straight line, and that is false. So that if it comes like that, what is the problem? Then there is high chance for the failure. Column will fail at that point because the lapping, or the lapping is at a particular point, means, see, this is all the lapping at a single line. So that means that point will be the most weakest point in that column when an earthquake occurs, or if a load increases, then that will be the point of failure. So in order to avoid that, we have to give lapping at different lengths. For that, we need to provide this length of the steel bar coming from the column shoe should be at different length. Understand? And the rule is that it should be less than 50% at a session. If you cut out the lap, you will get 50% or equal to 50%, less than or equal to 50% of the total lapping. It should be there. It should not be more than 50%. So that is the first point. Then second point is that how we are providing the lapping for the reinforcement bar, which you might be also knowing that, you know, in a video which I did before, I said that there are three kinds of lapping is possible. One is lapping. Lapping means one, you can place one bar on the top of the other bar. Other is by welding, by the use of coupling. If we are providing the lapping by putting one bar over other, okay, and binding it by a steel wire. So in that case, it should not be like this, one on top of it. It should be in line like this. That is, if this is the down bar, this is the bar from top. It should, there should be a slope of 1:6 at this area, and then provided the lap length, this from here to here, the lap length also should be adequate. It could be a minimum 30D, or maximum it can go up to 50D, where D is the diameter of the steel bar. And also note that D is the smallest diameter of the two bars. If the bar which is coming on top is less diameter when compared to the bottom diameter, though you have to take D as the diameter of the top bar. So 50D, D will be this bar. If both of them are same, then take the same diameter. If out of the two bars, which one is smaller, then we need to take. So one thing is that this 1:6 slope should be maintained, and this should not come this side. Okay, that is, it should be inward. At least you should know that this line should be straight. Okay, in this case, if it comes here, from top and bottom the line should be straight. Whatever the slope, it goes inside. So a column at a column section, this side it will go inside here, this side will go inside here. It should not come the opposite side. See, it should not come. This is inside. If this is the left side of the column, it should be like this. If this is the left side itself, it should not come like this. That is not correct. And one should not lap two rebar like this. Just like this, you are not supposed to lap it. Okay, this is the second point. The third point is that vertical ties. These stirrup like things, when we are using that ring in a beam, it is called stirrup, and when we are using the same ring in a column, it is called vertical ties. Okay, so when the vertical lies in which the lapping occurs at this area, okay, in this area, in that area we need to provide more vertical ties when compared to other areas. That means the shear force will be more in that particular area. So in order to counteract that shear force, in order to give more strength to the column bars, we have to give more vertical ties at that particular area when compared to the other area. So number of vertical ties in this area will be high when compared to the vertical ties in this area. Understand? And also maybe the spacing between the vertical ties will be less too. So when the vertical ties increases, automatically the spacing in between will be very less. That also need to be considered. Regarding the vertical ties in column and also the stirrup in beams, we know the bending angle here should never be 90 degree. It should be 135 degree. But in most of some of the sites where the engineer is not supervising good, there we can see the workers are, for their convenience, they are making use of 90 degree instead of 135 degree. So the site engineer should correct it to 135 degree. And why they are doing is that during an earthquake, it will come out. If it is 90 degree, the stirrup will open up because of the force that comes upon this column. So if it is in 135 degree, it will never come up. So it is a stable at earthquake. The vertical ties will be stable at earthquake. Even the stirrups are stable at earthquake. When that motion happens, it will not come out. Otherwise, it will open up. So we have to provide 135 degree, not 90 degree. Okay. And the last point is that all ends, the stirrup, if the vertical ties in the column, it should be at alternative direction. That is, one direction of the hook, one direction of this 135 degree ties bends are here, then the other one should be here, then the other one should be here, like that. It should not be at the same line. Sometimes we see that when there is no supervision, current supervision is not there, then the workers will provide the same pens at here, like that. It will go for their convenience, but we should not allow it. We should operate, and then it should be at alternative. Vertical tie should be at alternative direction. It should be there. One here, one here, one here, one here, like that it should go. So these are some of the points which we have to know, and we have to make it happen at site while we are doing the reinforcement of columns. Hope you understand the subject. So I will come with a new subject and in a new video. Till then, goodbye. Please subscribe, share and like my channel. Thank you very much.